All right, in this lesson, we will be talking about Venn diagrams and two-way tables. These are two different visual representations of data. So Venn diagrams, we'll start with those. They are how we compare the probabilities of two outcomes. Now, you've probably seen a Venn diagram before, just maybe not in the context of a math class. So what I'm going to do, we have a bunch of these tables for us, and they're each labeled something different. And the goal of this is to just shade some things in to kind of represent what these probabilities are. So let's say this circle in this first one represents the probability of event A. And this circle to the right represents the probability of event B. If I wanted to figure out what the probability of A is, okay, I'm focused on just this circle right here. But then if I jump over to the other side, if I'm worried about the probability of event B, I'm focused on this circle. So that's what I mean. We can shade these in different ways to kind of give us a visual representation of what we're talking about. All right, now if I look at the next two, this says a probability of A, and then there's like an apostrophe. This is the same as saying the probability of, oh my goodness, there we go. The probability of not A, okay? So if I go to shade this in, you might be thinking, well, that's just B, right? Like I should just fill in this other circle over here. That's a good guess, but that would be wrong. Um, we want to do anything outside of this A circle. Okay, so that would be just this part of B. Okay, but that would also be the surrounding space because the rectangle represents your total probability, 100%. And just because there's only two events, A and B, doesn't mean that there is a case where neither of them can happen. Okay, so that case would be outside in the box. All right, if we think about the probability of not B, it's very similar, except we're filling in the other circle. So again, just the part of the circle that's not touching B at all, and then all the surrounding area. So something like this. That's the probability of not B. All right. Now we got another weird new symbol. Okay. What if we talk about the probability of A intersect B? So this is intersect. And intersect just means and. So the probability of A and B, well, that is wherever both of those circles overlap. All right, so that would be in here. Oops. Okay, that is the only section of this diagram where both A and B are happening. Okay, now we do the probability of not A and not B. So remember this little symbol, this in means intersect, it means and. So the way I do this is I go back up top and I look at the probability of not B, and I look at the probability of not A, and I figure out where do those two, if I were to lay one of these diagrams on top of the other one, I'm going to shade in everything that the colors are touching. So it's, if you notice, everything is going to be shaded in except for this middle part. Okay, so when I go to do that, I'm doing this circle and then all the surrounding area. So something like this. So it's everything but that middle section. Okay, now I've got a weird symbol. It looks like a U. This means union. Okay, and union in math means or. So now we look at the probability of A or B. Now this one's kind of weird. We can go A, and we can go B. Actually, let's see, yellow for A. And we can do B. All right. And then we can actually go in the middle because it doesn't say we can't do both. It just says we're looking for the probability of A or B. Okay, this doesn't mean like A only or B only. It's A or B or anywhere where either of them touch. So it's just the circle part, not the surrounding. All right, now we think of not A or not B. Okay, so not A or not B. So that would be anywhere where we're touching not A or not B. And just like up here, A intersect B and not A intersect not B, see how those are just like exactly reverse opposites? In this one, the middle's filled in, but in the other one, everything but the middle is filled in. This is a very similar thing. So in this one, everything in the circles is filled in. In this one, everything outside the circles is going to be filled in. So I would do something like this. All the way around the outside of the circles. Like that. Okay, then if you flip it over to the back, we've got two last cases. It says probability of A only, probability of B only. So this means I don't want to touch B at all. So probability of A only would just be this little crescent part of the circle. Because if I go into the middle of the circle where they intersect, now I'm touching circle B, and I don't want to do that. And then very similarly, the probability of B only would just be the other circle. Okay, now, for each of these, there are formulas that we can kind of include in our notes. So if we go back up to the top of the front, the probability of A is just the probability of A. There's really not much I can do there. Similarly, the probability of B is really just the probability of B. Again, not much I can do there. But if I look at these, for example, the probability of not A. Well, assuming you know what the probability of A is, then everything else is just going to be 100% or 1 minus the probability of A. And then very similarly, for not B, we're going to take 1 minus the probability of B. Okay, now, if we talk about how do we calculate just this middle part, all right, we're going to put a star next to this because we're going to talk about that more on the back. But as a general rule, what you can do is take the probability of A, so this circle, take the probability of B, this circle, and add them together. Okay, now, this might be a little misleading because if I take the probability of A, I'm including this outer part of the circle and I don't want that. Same thing with B, I'm including this outer circle and I don't want that. And then if I add these up, I'm actually adding the intersection twice. So I have one extra section of this than what I need. Okay, so I need to figure out a way to subtract out this part of the circle, subtract out this part of the circle, and subtract one of these intersections. Well, if you look right below, this has everything I need to subtract right here. So I'm going to subtract the probability of A union B. And then I have my answer. Okay, now, uh, very similarly to the ones we just did above, if I want to calculate the probability of not A union not B, I'm going to take this formula that I just used and subtract it from 1. So I'm going to take 1 minus the probability of A minus the probability of B, and now plus the probability of A union B. Okay, so again, if I'm subtracting all of this, then all of the signs change. So this is now a negative PA, a negative PB, and a positive PA union B. All right, now I can talk about how do I calculate the union? How do I calculate this? So I'm going to take the probability of A, this circle, yellow, add it to the probability of B, that's the green circle. And then, but once again, remember, if you add both of these circles together, you are adding the intersection twice. So I need to get rid of one of those. So getting rid of the intersection looks like this. And you can see that these two formulas are very similar to each other. All right. Okay, now for this one, same deal. We're going to do the same exact formula and we're going to subtract it from 1. So I have 1 minus the probability of A minus the probability of B plus the probability of A and B. All right, now the last two. For the probability of A only, okay, you're going to take the probability of A, which is the whole circle, and you're going to subtract out just the part in the middle. So like that. And it's very similar for B. We're going to take the probability of B and subtract out the middle, and that'll tell us the probability of B only. Okay, so normally these diagrams also have like some numbers involved. So you might have been confused up to this point where are all these formulas coming from. Well, the formulas are based off of what we shaded in the picture. It's kind of like a puzzle. But normally, as an example, okay, we would say like, okay, there might be a 0.2 in there, a 0.3 in here, a 0.1, and then let's see, 3, 4, 5, 6. That would leave a 0.4 outside. Okay, so just as an example, this would mean I have a zero point 0.2 plus 0.3, a total of a 50% chance of event A happening. Okay, I have a 0.3 plus 0.1. I have a 40% chance of event B happening. I have a 20% chance of only event A happening and a 10% chance of only B happening. I have a 30% chance of both of them happening. And then outside, I have a 40% chance of neither thing happening. So that's kind of how this works. And I have to then like just double check and make sure that all these numbers added up equal 100%. So zero point 0.2 plus 0.3 plus 0.1 plus 0.4, that equals 1. So I'm good. All right, now we got to talk about some special cases for A intersect B. This is why I started. All right, so remember A intersects B, that's this part in the middle here, but there are some special times where it doesn't always equal that formula I gave you. So for the first thing is, if we talk about mutually exclusive events, that's when two events have nothing to do with each other. It's impossible for both of them to happen at the same time. So if it is impossible for these mutually exclusive events to happen at the same time, and I am told to figure out what the probability of A and B is, well, that would equal 0 because the circles don't overlap at all. So A and B is never going to happen. Remember, this would be like flipping a coin and getting both heads and tails. Okay, now we have our normal picture. And for dependent events, the formula is the same as the one I gave you before. So we're going to take the two probabilities, add them up, and then subtract A union B. But for independent events, the formula is actually a lot nicer. So independent events, remember, that's when two events do not impact each other. So this would be like the probability that you wear a red shirt in the morning, and then the probability that you get an orange juice for lunch. What you choose for lunch has nothing to do with what you wore that day. So these would be called independent events. To calculate this middle section on an independent event, we're going to take the probability of A and multiply it by the probability of B. Okay, and then the last thing we have is something called completely dependent events. Meaning, if you notice, if I call this A and this B, event B is entirely inside of event A. Meaning, if event B happens, that means event A definitely had to have happened first. Okay, they're completely dependent. So if this happens and you're told to figure out what the intersection is, well, the intersection of these two circles is the entirety of circle B because it's completely contained inside of circle A. So I would say this is just the probability of B, or whichever circle is inside. So it's just the probability of B because I labeled this circle B. If I had switched it, then this would be the probability of A. Okay, now let's talk about union. So now we're talking about A or B. Okay, now for mutually exclusive events, I want to know the probability of A or B. And I can do that because there are two circles here. And or means they don't have to touch. So to figure this out, I'm just going to take the A circle and add it to the B circle and be done. Okay, now for A or B in independent and dependent events, it's actually the exact same thing. So this would be probability of A plus probability of B minus the intersect. The only difference is that when we're talking about independent events, remember now that last part, A intersect B is equal to A times B. All right, and then last, completely dependent events. If we're talking about A or B, that technically means because both circles are inside of each other, that technically means I could just be anywhere in that bigger circle. So this is just equal to the probability of A, or whichever circle is outside. It's the outside circle. All right, very good. That is it for Venn diagrams. If you guys flip over to the second page, there's another way to compare probabilities and data. This is specifically used for like survey data. So you're going around and you're asking people a question or two questions and you're getting their responses. This is how you organize data for a survey. So I would make a quick note of that because you guys are getting ready to do a survey project. So this is how you organize data for a survey. Okay, and here's what I want you to do for this one. These are actually pretty straightforward. So what I want you to do is see if you guys can answer these questions below about this survey, and this will actually be part of the assignment for 1.A. So I will go ahead and label it assignment for, or did I say 1.A? I meant 1.8. And this will be part one of the assignment. Okay, so what I want you guys to do is try this. Feel free to, of course, double check it with me and then go ahead and turn that in.